Welcome back. For algebra, looking at 1.2, working with order of operations and evaluating expressions. Before we dive into this again, just a quick refresher. If you have any questions along the way, my email is here, ccortez@cohs.com. Keeping in mind, you can always ask me questions in class, always available through email. With this second section, working with order of operations and evaluating expressions, you might have seen this previously in pre-algebra, steps for applying the order of operations. What's nice about this section is that, let's say that you're trying to figure out some type of transaction, or you're using Venmo to split a bill with your friends, and you start to sketch out a bunch of this on a napkin, and it looks a little bit like, well, I had $84 on the bill, but I know that I had a $4 coupon, and I'm splitting it amongst, let's say, 8 people because it's your birthday. But then you remember that you have a little bit of money left on a gift card that might take off $250. Being able to evaluate situations like this is helpful because it can be a little chaotic when you're dealing with money transactions or when there are a bunch of numbers lined up with each other. Being able to follow through with how you would solve that, I think, is crucial to take this further into other math courses as well. So the steps that are seen here are going to help us break down sketchy situations like this where there's a lot going on, a lot of numbers, and help us find some total complete answer. So we'll first be looking at the grouping symbols, which, if you need a refresher, could be considered parentheses. They might be brackets, occasionally a fraction or a radical, but we'll see that in the next slide. We might see exponents where we might have some number raised to some exponent like 2 or 3 to the -1 exponent. So sometimes we have to simplify these. So 5 squared, we could rewrite that as 5 times 5, so 25. Continuing with multiplication and division, and that'd be going from left to right. So for a situation like 5 times 3 dividing by 1, the best route to take would be 5 times 3, which is 15, and then dividing that by 1. So notice we did multiplication first and then division because we were working from left to right. Adding and subtracting also from left to right if that's left over. So always focusing first on grouping symbols, which, as we see here, can vary depending on the type of problem we're working on. We might see parentheses, brackets. You might see a little bit of this, so be open to them. A fraction bar occasionally may show up, and also a radical. With the examples seen here, with the grouping symbols, this is denoting and just knocking out what needs to be simplified in the parentheses, so where this is being grouped. 6 minus 2, we can simplify that to 4. Continuing with exponents to evaluate this 4 to the third power. So if we have 4 to the third power, this is 4 times 4 times 4, which is then 64. Going from left to right with division, 64 dividing by 2 gets you 32. For a problem where this is a fraction, since we're working with the fraction, we just need to move to the next setup, which is going to be exponent. So 2 to the 4th, we can rewrite that as 2 times 2 times 2 times 2, which is 16. If you need a calculator for any of these, please feel free to go ahead and use one. Since we have 16 and we then have to deduct 1 up the top, this is still the group. We then divide by 5 because once we simplify 16 minus 1, that's 15. 15 over 5 is 3. So hopefully these examples have been helpful. For the first problem, we have a lot going on here, so let's rewrite our plan of attack with grouping, exponents, multiplication, division, addition, subtraction. You can really pick your poison as far as which grouping you want to work with first. I'll work on the first setup here first. So I have 68 dividing by 4. If you know this off the top of your head, kudos to you. If you need to use a fraction, please feel free. So we have, and not just throwing all of it in, 68 dividing by 4, 17. And the reason I'm not throwing all of this into the calculator is because sometimes you might just have to rely on your mental math to get you through this. We'll also see the answer in the calculator, but for this one, I'm going to evaluate as is. So we are then moving to the next grouping. So we're subtracting 3. This is the difference of 60 and 45, so 15. We're then adding on 2 times 8. Is there anything else that we need to group here? No, we're good. So grouping's done. There are no exponents, so we're good there. As far as multiplication, we need to take the product of 3 and 17. So if we do that, 3 times 17, it's 51. We're then deducting the product of 3 times 15, so 45. Finally, adding on the product of 2 and 8. This is the age you can drive, so what age is this going to be? Should be saying 16. Eventually, we're left with 51 minus 45 plus 16. Taking this from left to right, we've multiplied. There's nothing we need to divide, so that's done. Going from left to right here, 51 minus 45 is going to be 6. 6 plus 16 equals 22. Final answer. And again, I'm telling you to follow through with these steps and avoid using the calculator just to get the right answer. In time, you won't necessarily have your calculator on hand. For this one, however, we'll see what it looks like when it's all said and done. Sometimes it's good to check your work this way, but please keep in mind that you should be trying this on your own. As we see, we end up with 22, so that's good. For 3, we're going to skip 2 because that's just long division. You won't see too much of that. If you're curious, that answer there ends up as a decimal, so that kind of runs off. You should have seen this in pre-algebra, but 0.45 dividing by 0.5, 0.9. So you won't see this too much. If you do need a refresher on long division, let me know, but I'm skipping it. If we take this further, looking at example 3, let's see if we can focus that a little bit better. So with this, we have a fraction, so just so that we have our steps in check, grouping exponents, multiplication, and division from left to right, along with addition and subtraction. As far as grouping, we know we're working with a fraction, so that's good. Let's see if we can get this smoother. We know in the numerator we have the product of 5 and 9, and also the quotient of 18 and 3. Just won't get any smoother, huh? All right. Well, if we go for the top part, we have 5 times 9. Since we're grouping here, multiplication from left to right, 5 times 9 is 45. We're then adding on the quotient here of 18 and 3. 18 over 3, it's going to be 6. So that's the top. We also have the bottom part here where we have 2 plus 3 times 5. So we're still working with multiplication. So we're adding on 2 to 15. 45 plus 6 is going to get us 51. 51 over 17. I know what this is, but I might be a little unsure because it's using a fraction, and I never really have a denominator of 17. So 51 over 17 gets us 3. So grouping was already done in this one. There were no exponents here, so that was kind of nice. Multiplication and division, we knocked out a lot of that going from left to right. And then finally concluded with adding. And there's no need to subtract anything, so that was kind of nice. For section 2, for this one, they have us trying to find the value of the expression for where x is 5 and y is 2, given this equation seen here. So we'll see this again and again where we're plugging in numbers, and how I refer to this type of movement is with plug and chug, which is usually going to be something good that you're going to try and look for if we're working on a math context, because this is saying that we have some number given to us and we just have to plug it in where it makes sense. So in this case, we have, reading from left to right, x squared plus x minus 12 dividing by y squared. This is saying that x equals 5 and y equals 2. Luckily, this is kind of spread apart, this expression, so I'll just plug in where x is 5 first. So I have 5 squared, adding on 5, taking away 12, dividing by now 2 squared. Is there anything that we need to group here? Are there any exponents that we have here? Hopefully you see the exponents of 5 squared and 2 squared. So if we rewrite this, 25 plus 5 minus 12 dividing by 4. Is there anything that we can multiply or divide here? Hopefully you're saying 12 and 4. So I'll keep rewriting this anytime I end up with some new closure. So 12 divided by 4 gets us 3. If we take this from left to right, since we're now at the last 2 steps, so 25 plus 5 is 30. 30 minus 3 is 27. And we're good. And I say plug and chug again because I was given some value. I just plugged in to try and just evaluate what's going on. For B, we have the product of x and y being squared, then dividing by x and y. So we know what x is. We know what y is, so they're multiplying, being squared. This is dividing by the product of 5 and 2. So we've grouped, or no, we haven't even grouped. So we now have plugged in, but what should we be doing first? Can we group anything first? Hopefully you're thinking of grouping inside parentheses here. We have the product of 5 and 2. So this is considered grouping because there are parentheses. We want to get rid of those. We know 5 times 2 is going to get us 10. So we have 10 squared dividing by 10. So grouping's done. With exponents, can we simplify anything? 10 squared, we can rewrite that as 100. From here, multiplication and division. All we have is division left, so 100 dividing by 10 is just 10. These problems will definitely come back again when we're graphing. We see them again in Algebra 2 when we're plugging in and trying to get different values. We'll see this later on in the chapter and in the year when we're looking for patterns in an in-out table. So be on the lookout for where we just have to plug and chug, which is just a way for us to plug in numbers that are given to us.